Dear students, I am Moiz Etishamuddin, Assistant Professor of Mathematics at MVSR Engineering College, Autonomous, Hyderabad. This lecture is actually a revision lecture for Engineering Mathematics 3. So I tried to pick up very important top 30 questions so that if you revise it first place and then remaining other problems if you see, you will be getting most of the questions from this one because it is very nicely picked. So I have not covered all questions, but I have selected some very important 30 questions. In this PDF I have written that questions along with the solutions. So let's start now. First unit is about basics of probability. In that one I have avoided simple preliminary level questions. Directly the most important question is state and prove Bayes theorem. So the question is asking about stating and also we have to prove that Bayes theorem. So what is the statement of the Bayes theorem? It's there here. I'll scroll now. If B1, B2, so on up to Bn are mutually exclusive and exhaustive events of sample space S and A is any event of S. What is the meaning of that mutually exclusive? That is, if one of the event takes place, then other events, none of them will take place. For example, if B1 takes place, then B2, B3, so on up to Bn, no event takes place. And they are, in my way, I am saying that these n events are at the first level. After the occurrence of one of them, one thing more, it is mutually exclusive and exhaustive events. This exhaustive events means B1 union B2 union B3, if we take the union of all of them, that will become equal to sample spaces. And what is mutually exclusive? If you take the intersection, you don't have anything, means you have empty set. There is no point common, there is no outcome common to this B1 and B2. Similarly B2 and B3. Similarly B1 and B3 means Bi intersection Bj, where I and j are different, then Bi intersection Bj is equal to empty set. So only n events are mutually exclusive and exhaustive and A is any event of S. Then probability that if event A takes place, what is the probability that at first level? Actually A is second level event. First what is happening? B1, B2, B3, so on up to Bn, one among them is taking place. Second level, after the occurrence of one among them, event A is taking place. So if event A has taken place, in the background what happened? Either B1 has taken place or B2 has taken place, so on up to Bn. What is the probability that B3 has taken place if A is taking place? Let me say reverse. If A is taking place, what is the probability that first level B3 has taken place, for example? Then we are calculating P of B3 by A. P of B3 by A, you can also calculate P of B2 by A like that, some K here. Then how to remember this statement? This conditional probability, you take a reverse here, that is A by Bk. P of Bk by A is equal to P of A by Bk, and this Bk will come in the numerator. And denominator, this same format, that instead of K you write I. Then take the summation from I equal to 1 to n. All the terms will come. Suppose Bn is B10 for example. So I equal to 1 to 10. P of B1 into P of A by B1 plus, because summation is there here. So what will be the first term of this summation? P of B1 into P of
A by B1.
A by B1, very good, plus P of B2 into P of A by B2. So on up to P of B10 into P of A by B10. N terms will come here with this product and only one among such a product will come here. Suppose if I am calculating out of 10 mutually exclusive events, suppose I am calculating probability of B3 by A, then 3 will come here, 3 will come here, it is third term of this summation. Remaining all the, here it will be completely 10 terms. Only one term comes in the numerator. I hope you understood. Now we need to prove this one. We'll go for the proof of this. Okay, the proof starts with very simple thing by the definition of conditional probability. What is the left side here? Same thing I am copying. So as per definition of conditional probability, in the numerator the intersection will come for this, and denominator here it is A, same A comes here. This is by the definition of conditional probability. What is the definition of conditional probability here? P of x by y, suppose x by y, then x intersection y comes here and that y comes here. So because it is bk by a, the intersection is there, bk and a intersection, and in the denominator this pa appears. Understood up to here? That is equation number 1. This is left side of Bayes' theorem. Now don't see the right side, we have to prove that one. So first step is this one. Now we are going to replace this and replace this one by using next equations. Now you see, I need to represent this one in another way. So we know that P of bk intersection A is P of bk into P of A by bk. What is the meaning here? bk is taking place and A is taking place. So bk is taking place and bk has taken place. Then what is the product getting? A. That is nothing but this numerator. That is number 2. By the theorem of total probability, if I want the total probability of event A, then I will use the summation. I'll write all the n terms, P of B1 into P of A by B1 plus P of B2 into P of A by B2. That complete summation is the value of P of A by theorem of total probability. Now, you just see first equation, you are having numerator this much. That is nothing but represented in this way, in the second equation. And this denominator P of A is this summation. What I am going to do, I am using second one and third one, means this one and this one in number 1. So I will replace this one, I will get back this one, P of bk into P of A by bk, and instead of P of A which we are having here, this P of A is nothing but this summation. That summation is substituted here. That is nothing but the ends of proof. So simple. Hence proved. Now we will go for a problem on Bayes' theorem. Box A contains 3 red and 7 black balls. Two colors are available, red and black, and this is how many colors are available, right? Similarly, box B is having 4 red and 10 black, means 2 colors are available. See the point very clearly. You are having the point here that if a box is selected at random, so that 2 boxes are there, box A and box B. Somebody kept as per box A and box B this type of color, this type of balls, and that 2 boxes are brought in front of us. I don't know which is box A, which is box B. So from that 2 boxes, I am selecting one box at random, and from that box, I am not looking into that box. I am just taking, suppose box is here. I am looking at that side and I am picking a ball. That ball may be red or that ball may be black, because these are 2 colors. Now, a box is selected at random and a ball is drawn at random. This much is the process taking place. So what is asked in this? What is the probability that the
ball is
black?
Yes, sir.
There are two questions here. What is the probability that the ball is black? That's one thing. Second bit of the problem is, if the ball is black, first of all we are calculating what is the probability that it is black. Second question is, okay, the ball is removed from that, I am looking at that side and I have taken. If it is found to be black,
Yes, sir.
what is the probability that it has come from box B?
Block.
It came from box
B.
B. It might have come from box A. It might have come from box B. What is the probability that it came from box B?
Box B.
That probability also we are going to calculate. Now we are going for the solution of that. Let A be the event of getting a
Black ball.
black ball. But try to understand the logic of the problem. First box is selected or first ball is selected?
Box is selected.
Very good, very fine. First box is selected. So box A may get selected or box
B.
B may get selected. Later on you are throwing a ball.
Yes, sir.
That is red or that may be
Black.
black. The event of getting a black ball I am calling A. And in the background box selection, it may be box A, it may be box B. That I am calling as E1 and E2. Which we have done B1 and B2. Here just I have changed the names. So
E1.
what is E1? E1 is the event of getting box A. E2 is the event of getting
Box B.
box B. And A is the event of getting black
Ball.
ball. So it's written here. A is the event of getting
A black ball.
a black ball. E1 and E2 with the events of
Selecting
selection
a
of
box.
box A, box B respectively. Means E1 is for A, E2 is for
Box B.
box B. What is the probability of event E1? Just E1 is selection of box A. It may be box A which I selected or it may be box B. So 1 by 2 and 1 by 2 are probabilities of E1 and
E2.
E2. That's fine. Now black ball may come from box A, black ball may come from box
Box
B.
B.
So two components are there. So E1 takes place and A takes place. This is one possibility.
Yes, sir.
E2 takes place and A takes place. So A is taking place after E1 or
E2.
E2. So E1 takes place and A takes place, or E2 takes place and
A takes.
A takes place. These two possibilities are there. So I need to add the probabilities to get the total probability of event A. So by theorem of total probability, P of A, by theorem of total probability, P of A is P of E1 into P of A by E1. What is the meaning of A by E1? Event E1 has taken place.
Yes, sir.
What is the probability of A takes place?
Yeah.
We may get a black ball, we may get a red ball.
Red ball, yes,
but
sir.
but probability that
Getting a
ball
black
is
ball.
black ball. Okay. So even gets cancelled. P of A comes like that. Somehow you remember.
Yes.
So this is one part of P of A. On the left hand side we have
P.
P of A.
A.
That P of A, some part is this part, another part is this part.
Yes.
E2 gets cancelled, A comes like that. Somehow you remember. So you are doing all possibilities and adding. P of E1 is 1 by 2, that you know very well. What is the meaning of this? E1 has taken place and A takes
Getting a black
place. Getting a black ball. Very nice.
Yes.
So if box A is selected, what is the probability of getting
A black ball.
black ball? So now come to the readings, means given data. Okay, good. Box A is containing 307
7 black.
black balls. Because one ball is selected, that we need from 7.
Yes, sir.
And that 7 chances are there to get a black ball. But total balls are how much? 3 and
10.
7. So 10. So what is the probability of getting a black ball?
7 by 10.
7 by 10. So nice. What is the probability of getting black ball from box B?
10 by 14.
10 by 14. So nice.
Yeah.
So 10 chances are there that we may get a black ball. Totally there are 14
14
chances.
balls. Yes, sir.
So 10 by 14. What is the 10 by 14? The 10 by 14 is P of A by E2.
E2.
A by E2. So we are just substituting the values. A by E1 is 7 by 10.
Yes, sir.
Again P of E2 is 1 by 2.
1/2.
10 blank balls out of 14
14
balls.
balls.
14 balls I am saying, just
Yes,
means
sir.
red and blank together. So 10 by 14. Now this is simplification. I don't want to enter and waste the time and simplification. You can get it.
Yes, sir.
Okay, fine. Now this is very interesting question. First we were interested in counting or calculating the probability that ball is black.
Yeah.
But in second part of the problem, ball is found to be
Black.
black. What is the chance that it came from box
Box
A,
A and box B.
box B? There are different chances.
Yes.
So we are calculating the chance that it came from
Box
box
B.
B.
Yes,
Box
B.
B means event E2 has taken place, first level, then A has taken place. So how do we need it now? We need ball is black. Keep in mind, in conditional probability, after the slash, whatever event name is there, that has taken place. And in first level, what is the probability that E2 has taken place? Means, if the ball is black, you have to read always first this event, then come to this event in conditional probability. Now, what is the meaning of this one? If the ball is black, what is the probability that
Getting
box
from
B
box B.
was selected first? By Bayes theorem, you know very well, BK by A was written.
Yes, sir.
Now it is E2 by A.
Yeah.
This E2 by A, immediately reverse it as A by E2.
Yes, sir.
Are you able to understand this?
Yes, sir.
This I am interchanging in this way.
Yes.
And this E2 is the denominator. So you write E2 here. This is how you have to remember.
Yes, sir.
And once you are written for E2, this is of second part.
Yes, sir.
In first part, you will be having even. Same type of products will come. Among n products, only one term comes in the numerator. Suppose if you want to know what is even by A, even it will be here.
Yes, sir.
P of A by even.
Even.
This is appearing here. Second will be there as it is. I
Yes,
hope
sir.
you understood.
Yes, sir.
So what is this one? That is written here with the probabilities. Are you following?
Yes, sir.
Very nice, good. So again,
Simplification.
just simplifications. 1 by 2 for this P of A2, 10 by 14 for A by A2, all these things.
Yes, sir.
Okay, fine. Now we are at question number 3.
Yes, sir.
Define the following: random variable, discrete random variable, continuous random variable, probability mass function, probability density function, and expectation. We are defining this.
Yes, sir.
For a bit, that is random variable, if S is any sample space, then a function x from the sample space to real numbers is called random variable.
Variable.
Just you need to remember this one, but I'll give a little introduction about that, just little introduction. S is sample space means it contains outcomes. R is set of real numbers. So what this x is doing, it is taking outcome and attaching it to real number. So second outcome with some real number, third outcome with some real number. All the outcomes are attached with
Real number.
real numbers. For example, I am taking 2 dice. I am tossing it. I may get 1 on this and 2 on this.
Yes, sir.
That is one outcome.
Yes, sir.
I may get 6 on this one and 5 on this one. Suppose 2 different color dice are there, different color.
Yes.
So 6 5 is different, 5 6 is different. 2 different color dice.
Yes, sir.
Now this outcome I need to convert into a single number. Then x can do like this. This x is the sum of 2 numbers appearing on the die. Then what happens? 1 comma 2, it will attach to 3.
3. Yes, sir.
This it will add the 2 numbers and convert it to a single number.
Yes, sir.
4 comma 5 will be converted to a single number, that is 9.
Yes, sir.
Okay? So that x which attaches a real number to an outcome is called random variable.